Welcome to Mathlink Academy, where we connect the dots. I am Mr. C, and in this unit, we're going to talk about the product and quotient rule and finding derivatives. We're also going to introduce trig functions using the product and also the quotient rule, and possibly look at higher derivatives. So let's get started. So let's talk about the product rule. Again, when we say the word product, we mean multiplying. So the product of two different functions, f and g, is itself differentiable. Moreover, the derivative of f times g, and that's when we say fg, f times g, is the first function times the derivative of the second function. So if we have a function, two functions multiplied by each other, f of x times g of x, to find the derivative, it's going to be leave the first function alone, take the derivative of the second function, g prime, plus leave the second function alone, and then take the derivative of the first function, f prime. So let's look at a quick example, how to use the product rule and why we use it. So let's say we have a function, and we'll get started with this particular function. Let's say we have y is equal to two functions. Let's say x squared plus 1 is one function, and that could be considered as your f of x, and your other function, we're multiplying it by 2 minus x cubed. So we have two functions, x squared plus 1 times 2 minus x cubed. Now what we want to do is find the derivative of the product of those two functions. Now there's another way to do it, but for this particular example, we're just going to look at using the product rule. Since we're multiplying two functions, and I'm going to underline the two functions again. This is one, that's my underline, really a curved line. And here's my other function. We could call that g of x. Then we're going to use the product rule up here to find our answer. So let's do this. So y prime is going to equal to, leaving x alone, or f of x alone, it'll be x squared plus 1. And what we do, we take the derivative of the second function. Well, the derivative of the second function will be, the derivative of 2 is 0, and the derivative of negative x cubed, we'll use the power rule, will be a negative 3x squared. And since the first one is 0, I don't have to write down 0. Now we're not done. Product rule says here, then we say plus, we take the second one, which was 2 minus x cubed, times the derivative of the first function, which was x squared plus 1. The derivative of x squared plus 1 will be 2x. Now in this case, we just multiply and see if we can add like terms to simplify to get our answer. So for the first term of multiplication, we're going to multiply this value, this function, I should say, to this one and x squared. And then for the second part, we're going to multiply 2x to here and to there. So let's do that. So for the first part, we're going to end up with a negative 3x to the fourth power, because we're multiplying negative 3x squared times x squared, and then negative 3x squared times 1, which would be a negative 3x squared. Let's do the same thing for our second terms here. So 2 times 2x will give me 4x minus 2x to the fourth. Now the next step, you want to make sure, are there any like terms? Again, you can look at my previous videos or other videos that we have in our Mathlink website to see if we learn how to add and subtract like terms. We do have like terms. The first and the last two are like terms. So we're going to combine them, and that will finally give our final answer for this particular problem. And so our answer will equal to, once we combine those two numbers, we're going to look at the coefficients, -3 and -2. We're going to add them together. That gives me a -5, x to the fourth minus 3x squared plus 4x. And there are no other like terms, so I am going to circle this. And that will be my answer of y prime using the product rule. Let's look at another problem. So we're at our whiteboard, and I have this problem, 3 minus 2x squared. So that's, we could say that's like a f of x times, again, product rule, times another function, times 5 plus 4x. So to find the derivative of two functions being multiplied together, we're going to use the product rule. And how does that look? We're going to say y prime is equal to, we're going to leave the first one alone. So this will be 3 minus 2x squared times the derivative of the second one. The derivative of 5 plus 4x is just 4. Because the derivative of 5 is 0, and the derivative of 4x is 4. Then we say plus, we write down the second function, 5 plus 4x, and we multiply that by the derivative of the first function, this first function that is here. So derivative of 3 is 0. This would be minus 4x. Now, what we're going to do, we're going to multiply this 4 times the first and second term, and there's negative 4x times this first and second term here. And then we're going to see if there are any like terms, combine them, and then circle our answer. So this is equal to, if we do our math correctly, it's going to be 12 minus 8x squared. Do you agree? That's that first term. What we're doing, we're using the distributive property, plus, in this case, I'll say negative, I'm putting parentheses so you know I don't lose my negative, negative 20x minus 16x squared. Now let's see if are there any like terms. In this case, I look like I have this negative 8x squared and negative 16x squared. Those are only like terms. So let's combine them and write our final answer. So y prime, and I like to write them in descending order far as the powers or the exponents. So we combine what's underlined in blue, that would give me a negative 24x squared. And the next one I'm going to write is minus 20x, and then I'll write the constant plus 12 last. You don't have to do it that way, but that's normally how we do it in math. And if you have answers in the back of books, they're usually going to write it in this particular way. And then that's our answer. Now, let's see about doing this problem a little bit differently by not using the product rule, but using the power rule. Sometimes it's quicker to use the power rule. Sometimes it's quicker to use the product rule. It depends how you see it. So here's the same problem we just did, and we're going to do it a different method that you could see or might have saw it before I did the product rule. What I'm going to do, I'm going to use the FOIL method and write out all the terms for using the FOIL method. So I'm going to rewrite this y equation. I'm not going to take the derivative yet, so let's rewrite this. So using the FOIL method, again, we discussed this in algebra. So go to the algebra section of the Mathlink website, and you can see how to use the FOIL method, which stands for first, outer, inner, last. And so for our first term, and these are our first term, this gives me 15. First outer term, which would be the 3 and the 4x, you multiply those together, that gives me 12x. The inner term, which would be the negative 2x squared and the positive 5, I just underline those two, will give me a negative 10x squared. And the last term, which I put on the top, will be a negative 2x squared, and 4x will give me a negative 8x cubed. So I'm going to rewrite this particular problem by expanding it using the FOIL method. So another way to write this problem will be, and notice I'm going to write it 8x cubed. I'm looking at my first, outer, inner, last answers, and I'm going to put them in the order that is normally written. Minus 10x squared plus 12x plus 15. Now we have a problem that has 4 different terms, and we could just use the product rule we could use the power rule. Make sure we get the right P. The power rule, and also the constant for the n. So find y prime, watch this. This would be a negative 24x squared. That's using the power rule. Minus, in this case, I got 20x plus 12. The plus 15 would become 0, so we don't put plus 0. And then I'll just circle that. And that's what I end up with. Now let's see that answer compared to the answer we had before. What I put in square, I call it circle, but what I circle in blue is the same answer what I circle in orange. So we have the same answer using 2 different methods. Now the quotient rule is a little more involved, but you should memorize this because there's a pattern. The quotient rule, which again, we're talking about dividing. That's what we talk about, a function f divided by g. It can be written as f of x times g of x. To find the derivative of this, I'm going to clear it so you can see what I'm saying. It's going to be, and I'll usually start at the denominator. Derivative is going to be g of x squared. So whatever the denominator is, you square it. And then you bring it up to the top, to the numerator. It will be g of x times f prime of x minus, and that's important, it's minus in this case, f of x times g prime of x. So you see some little or some flavor of the product in the numerator, but you got to make sure you keep it in that same order because of that minus sign. If you don't, you're going to end up with the wrong answer or a negative of what you want to get. So for example, let me give you a quick example of a function that we can look at. So let's say y is equal to, and then we're saying product rule, the quotient rule, and therefore let's look at a fraction. So let's say we have x on the bottom, and then on the top, let's say we have 2 minus x squared, okay? So that is a quotient. Our top is f of x is 2 minus x squared. We can say that's f of x. And the bottom, x can be conferred or looked at as g of x. Now to find y prime, let's write down y prime. Let's look at our quotient rule. It says this. We square, I like to start with the denominator. We square the bottom, so it'll be x squared. And then that x would be on the top, that's our g of x. And you take the derivative, I'm gonna use a different color so you can see how I'm doing this, of our f of x, which is the top, which is 2 minus x squared. So that would give me a negative 2x. Again, don't forget we minus the original top, which is our f of x. So I'm just looking at the quotient rule. 2 minus x squared times the derivative of g of x. Now, g of x in our case is this x here on the bottom. And in this case, I'm going to write it in green so you can see I took the derivative. The derivative of x is just 1. Okay. Now, what you'd like to do is simplify the numerator. So what we would like to do is simplify the numerator. So in this case, I could say, and I'm just multiplying x times negative 2x. That would give me a negative 2x squared minus, and then this would be, now notice that minus is with everything after the parentheses. So this would be a minus 2 plus x squared. Now anything multiplied by 1 is itself. And then the denominator on the bottom is x squared. Now in this case, I would, and I think you see in the numerator, see if you can simplify it. And so we have like terms. We have a negative 2x squared, and also we have an x squared. So what you do, you just add those together. And so let me write it over here so you can see the final answer. So the final answer, I'm going to write the final answer in red, will be a negative x squared minus 2 over x squared. And that would be my y prime. Now, even though I don't have a lot of room to show the work, you can see each step how I got where I got it. And I'll show you also another answer or even another problem on our whiteboard. So here's another problem. And the question is, find the first derivative, or take the derivative of the function y. First thing we notice, it is set up as a quotient. So we're going to use the quotient rule. And we want to memorize this quotient rule. So the quotient rule says this. To find y prime, so let's write that down. The denominator, you square it. So x squared plus 1 is one of your functions, and you square it. Then that same function, x squared plus 1, will go in the numerator. And then you take the derivative of 5x minus 2, which is just 5. Then you have subtract. Don't forget there's a subtraction. And then you write down 5x minus 2. And then take the derivative of x squared plus 1, that denominator. And the derivative of x squared plus 1 is 2x. And so that's the quotient rule. Now you got to simplify your numerator. So in this case, we end up with 5x squared plus 5. Now watch how I'm going to do this. Minus, I'm going to put the minus here and still keep I'm going to keep this as a bracket. So I make sure I don't lose my negativity on everything after the bracket. So it'd be this times that, this times this. This will give me 10x squared minus 4x. Now, again, I'm going to simplify this numerator. Now this gives me 5x squared plus 5 minus 10x squared plus 4x. We're distributing this negative to each. And all that's divided by x squared plus 1 squared. And all you need to do is look and see, can we combine anything in the numerator? And in this case, we can. I will circle the ones we can combine. You combine this one and this term. And don't forget, that's a negative 10x squared. So as we look at the coefficients, let's see if I can squeeze it in here, guys. So I'm going to squeeze it right here. So that would give me, and also I'm going to write this, a negative 5x squared plus 4x plus 5. I'm writing in decreasing order as far as the exponents. And then the denominator would just be x squared plus 1 squared. And I was able to give our answer out on our whiteboard. And that is the derivative. So that's what y prime will equal to. So let's also talk about trig functions, the derivatives of trig functions. These are things we should know and try to put in the back of your mind. The first thing is the derivative of the tangent of x is the secant square of x. So the derivative of the tangent of x is the secant square of x. The derivative of the secant is secant tangent of x. And then the derivative of the cosine of x, or cotangent of x is negative cosecant square. So something like there's some relationship between these two, if you can see a similar pattern. And the derivative of the cosecant of x is a negative cosecant x cotangent. Now also remember, we also say the derivative, so I could say this, d dx of the sine of x is equal to the cosine of x. Again, we looked at that as in past videos, and you can look at some of my supplementary material to find that. And the derivative of the sine of x, you got to know this one, is equal to the negative cosine of x. So those are the other two that we have discussed previously. I will say if you know this will help you know the right column. So again, the tangent, the derivative of the tangent of x is the secant square of x, and the derivative of the secant of x is equal to the secant x tangent x. Okay, so let's look quickly at some functions and some examples using the trig functions, finding the derivative. So let y equals x minus the tangent of x, then dy dx, another way of writing derivative, will be 1. So this is equal to 1. And what's the derivative of the tangent of x? Is the secant square of x. So this is our answer here. Let's look at another one. Now in this case, I'm actually going to do this one. This is x secant of x. So we're going to go on our whiteboard and look at x secant of x and see how we get our answer. So here's our problem. We have y is equal to x secant of x. And we want to find the derivative. Now notice it's y prime is going to equal to, this is a product, two functions. You have x as being one and secant of x being another function. So in this case, I'm going to use the product rule. And in the product rule, we'll say we take the first function, which is just x, and then we multiply it by the derivative of the second function. I'm going to write that in blue. So what's the derivative of the secant of x? The derivative of the secant of x is secant x tangent of x. And then we say plus, and then we write down, then we say the derivative of x, and the derivative of x is 1 times the secant of x, the original of the second. So in this case, we end up with x secant of x tangent of x, and again, these are multiplied together, plus 1 times secant of x is just secant of x. And we can have that as our answer. Now, if you want to factor out and say, hey, Mr. C, I want to factor out what's common in each term, you can. So you can say secant of x, factor that out because that's in both of them. And we're left with in the bracket, x tangent of x plus 1. And so that's another way you could write it. Now, the last thing is showing you how to write higher order derivatives. It's just notation that we're just going to look at. So what we've been doing today is the first derivative, and how you write that, you can write as y prime, f prime of x, or you can say dy dx. All of these are equal to each other. Or you can say find the derivative of f of x with respect to x, or a d operator. We don't talk about that a lot, but that's something we talk about in calculus 4. So don't worry about it now, but that's another way of writing the first derivative. For the second derivative, you just use double primes. You say y double prime or f double prime of f of x, or you can say the second. Now notice how this is written. This is the second derivative with respect to x. And notice the square here is right here and right here, or you can write it with the function of f of x. With the third derivative is 3 primes, y triple prime, f of x, triple prime. This is the way you write it, and this is the other way to write it, and then you also have your d operator. Now, after the third derivative, you don't just keep doing primes. We can continue with all these primes and forget which one we're at, 5th, 6th, 7th. You know, how you do 100 primes? No, you use the numbers. So after the third, when you get to the fourth, you just say y to the 4. And what you notice, you have a parentheses. And this would be f to the fourth derivative. If you didn't have a parentheses, that means to the 4th power. And so this would be how you write the fourth derivative, and that's the d operator. And so for the 5th derivative, and it's showing you the nth derivative, but let me just show you the 5th derivative. You say y to the 5th power. You got to put that in parentheses, or you can say f of x to the 5th power. And you don't want to say power, you're saying the 5th derivative, excuse me. So you want to put that in parentheses so you know you're talking about derivatives. Put those 5 in parentheses and do the same thing with the remaining ones. And so that's how you write higher order derivatives. Now, in order to find these derivatives, I'm going to clear this. In order to find the first derivative, we know how to do that. The power rule, also the product, the quotient rule. We know how to find that. And then there's one more called the chain rule. But in order to find the second derivative, you got to first find the first derivative. Once you find the first derivative, you take the derivative of the first derivative, that gives you the second. Now to find the third derivative, you got to find the second derivative and take the derivative of the second. You got to take the derivative of the second derivative to find the third derivative, and so forth and so forth. So let me show you an example of one, and then we'll stop there for today. So let's say we have a function. I'm going to call this f. Let's say f of x is equal to 5x cubed plus 2x minus 1. Now to find the first derivative, we'll say f prime of x. In this case, we're just going to use the power rule. And so this would be 15x squared plus 2, and the derivative of -1 is 0. So that's my first derivative. Now to find the second derivative, we say f double prime of x. That's going to equal to 30x, and the derivative of 2 is 0. Now to find the third derivative, we got to take the derivative of the second. That will give me just 30. And to find the fourth derivative, and notice I'm writing down in parentheses with the 4, so we know that we're doing the fourth derivative. What's the derivative of 30? Since 30 is a constant, it will be 0. And that is the answer of finding the first, and then the second, then the third, and then the fourth. Hopefully this helped how to find the derivative using the product and also the quotient rule, and also introducing some more trig functions. Again, if you have any questions, again, look at this video again and look at our supplementary material that we have for our Mathlink website. Again, let Mathlink bring it together.